Traditional methods for aligning language models with human preferences have limitations. These methods struggle to capture the complexity and unpredictability of human preferences. Recent advancements suggest that working directly with preference probabilities can lead to more accurate results. That is where this sppo or self play preference optimization method comes in. This is a new approach which treats the alignment problem like a game between two players, seeking to find the optimal balance, and that balance in terms of machine learning is called as Nash equilibrium. This method iteratively updates policies to approximate this equilibrium, ensuring theoretical convergence. In this video, we are going to locally install this Gemma-2 9 billion instruction tuned self-play preference optimization with iteration 3 method. Now you know what exactly this self-play preference optimization is. Now when we say iteration 3 or iter 3, what it means is that it refers to the third round of refinement or update in the self-play preference optimization process. SPPO is an iterative method that involves repeated cycles of generating responses, then evaluating preferences, and then updating the model. The goal is to converge towards a better alignment with human preferences. So, as you can see that in this model, self-play preference optimization was used at iteration 3 and it is based on Google's very impressive Gemma-2 9 billion instruction tuned architecture as starting point. We have covered this Gemma-2 a lot in our previous video, so please do search the channel. Gemma is a family of lightweight state-of-the-art open models from Google built from the same research and technology used to create the Gemini models. They are text-to-text decoder-only large language models available in English with open weights for both pre-trained variants and instruction-tuned variants. And this one, as you can see on your screen, is IT or instruction-tuned. So let's go and try to get this thing installed and we will then play around with it. Before I do that, let me give a huge shout out to Mass Compute who are sponsoring the GPU and VM for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video description, and I'm also going to give you a coupon code of 50% discount which you can use with a range of GPUs. Now let me take you to my local system or local VM where I'm running Ubuntu 22.04 and the GPU card which I'm using is this NVIDIA RTX A6000 with 48 GB of VRAM. Let me clear the screen. Let me create a Conda environment which will create a virtual environment with the name of Gem2 to keep everything nice and simple. So let's wait for it to get installed. Okay, sorry, I think I missed the C there. So let me put the C in here. Now it should install fairly quickly. Shouldn't take too long. And that is almost done and it has also activated it. Let's install some of the prerequisites. First up is Torch. So let's wait for it to get installed. Torch is installed. Let's also install the transformers with dash capital U, which will upgrade it. And make sure to install the latest version of transformers because otherwise you won't be able to run this. This shouldn't take too long. Let's wait for it. And that is done. Let's also install accelerate, which is to optimize, and that is also done. Let me clear the screen. Let me launch my Python interpreter and then we will start installing this. Let's import some of the libraries which we have just installed, and that is done. Let's also import the torch here. Let's grab the tokenizer for the model. That shouldn't take too long. That is done. And now let's download the model. So I'm simply just giving the repo name from Hugging Face and then device map to auto, which is going to put it on my CUDA device or GPU. And then I'm just specifying this data type. And now it has started downloading the model. There are 4 shards of it, just close to 5 gig. So let's wait for them to get downloaded and then we will proceed further. It shouldn't take too long. So the model is downloaded at last, and also it has loaded onto my GPU as you can see here. Let me clear the screen by using this lambda, and screen is cleared. And now let's test it out. The first question I'm asking it is quite famous. So this is in this question, what I'm asking it is this that it's a classical cognitive bias example, by the way. So it is saying a bat and a ball cost a total of $1.10. The bat costs $1 more than the ball. How much does the ball cost? If you have said that the ball cost 10 cent, that is wrong. So let's see what model thinks here. Should be fun. So let me pass the input IDs uh, to the tokenizer to convert this text to tokens. Let's ask the model to generate output. Okay, so I just need to set the max token, which I forgot to do as usual. Let me clear the screen and properly set it. Sorry about that. Got too excited. And now as I have used the max new token as 1024, you can see that it has broken down the problem into very step by step fine way. So x is equal to cost of the ball. Since the bat cost $1 more than the ball, we know that the bat cost x into 1. Total cost of bat and ball is this. Now we can solve for x, which is x is equal to 0.05. So the ball cost 5 cents, which is extremely correct. Amazing stuff. So for me, the model has already passed the test with flying colors. Let's try out one more prompt. Okay, so another question is that a snail is at the bottom of a 20-foot well. Each day it climbs up 3 feet, but at night it slips back 2 feet. How many days will it take for the snail to reach the top of the well? What do you think? Let's try out with model while you think, and then I will also give you the answer. Okay, so the correct answer is 18 days. So let's see if model gets it right or not. So let's wait for it to come back. It is still thinking. So the model has come back. Let's see what model says. And you see on the 18th day, so it has solved it properly, and it is towards the end it is saying on the 18th day the snail climbs 3 feet and will reach the top of the well. How good is that? Amazing stuff. Let's clear the screen and let's try the final one. Now in this one I am asking it, a farmer has 100 feet of fencing and wants to enclose a rectangular area with an existing barn as one side. What is the maximum area he can enclose? What do you think? While you think, I'm going to ask it from the model. Let's see what model says. And I will also give you the answer shortly. So the answer is 1500 square feet. Let's see what model says here. And the model has come back. Let's check it out. So if I check it, okay, so because I had just put in um, the context length to 1500, as you can see, maybe for this one I'll just increase this to maybe 1000 to see if what it does. So let's wait for it to come back and then we will see if the answer is correct or not. But so far, if you see, the train of thought which model has followed is sublime. Really, I mean, define variables, set up equation, parameter, express area, find the maximum area. Amazing stuff. Amazing. I wouldn't be able to do it in maybe the whole day. Okay, so let's wait for it to come back. Okay, so the model has come back, and let me print the response out. There you go. So it says nope. So in this one it says 1250 square feet, whereas ChatGPT tells me it is 1500 square feet. So I will let you to decide. I think it is 1500, but anyway, but still, regardless of this, I think the model's performance is supreme. Really amazing. Just 9 billion, and look at this with the after iteration 3 in self play performance optimization. Let me know what do you think. I will drop the link to models card in video's description. If you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.